It's the urban legend, flying through that road with straight greens, but with heavy cross-directional flow, it's still only a legend. You see, basic traffic lights work through one of two simple mechanisms. The first is through pre-established timing plans that regulate green-red cycles, and the second is through pavement loop detectors, which can tell when a car is waiting for a green. With heavy traffic in multiple directions and variable fluctuation, these mechanisms are way too primitive for busy cities. Traffic lights, just like smartphones or any electronics, need to evolve. These days we have cameras and wireless capability of detecting how many cars are passing and when they're passing. Once we've gathered this information live from the traffic stream, the problem just becomes a big math equation where we're just looking for optimal green-red distribution. And like any optimization problem, the answer is intuitively simple. You let a computer take over. This of course requires a fancy control center and direct communication between intersections and that control center. But can we do it without an expensive mecha command center? Just recently, computer chips have become small and smart enough to actually fit inside a traffic light. Infused with artificial intelligence, the possibilities open wide. So, meet MARLIN, a new breakthrough that gives traffic lights the ability to self-learn. What MARLIN does is gather traffic pattern information in real time, and then it learns how to move it all with the least amount of delay. Like any smart technology, MARLIN is able to sense, think, learn, and adapt, helping us move more and stop less. But traffic isn't just singular and isolated. Just like a team works together to move a ball around, MARLIN has the ability to communicate with other traffic lights in the surrounding area to efficiently collaborate and manage traffic flow. Essentially, MARLIN-controlled intersections collectively use game theory to coordinate the most efficient distribution of green and red lights in real time. It puts the intelligence right at the traffic lights, allowing them to anticipate and react just like skilled teammates do. This reduces the need for continuous communication with a command center and the need for skilled human operation at that command center, while also avoiding any single points of failure. Of course, what drivers want are results in numbers, and MARLIN has been tested on a virtual computer model of 60 downtown intersections during rush hour in Toronto, Canada. Reductions in delays were seen by up to 40% on average, and total travel times were cut by about 25%. As you can see, MARLIN is self-learning, extensible to any number of intersections, requires little human operation, cuts delays in travel times, lowers our carbon footprint, and can ultimately help the hundreds of big cities around the world where congestion is just out of control. And maybe most importantly, how about a little less stress on those roads?